A few years ago, I won a couple of these linear rail systems at an auction. In an old video, I took the larger one of the two apart, and I've always thought that'd be a useful project for some point in the future. Now is the future. I have a fancy new camera. I think it would be good to use the smaller one, this one here, as a motion system for moving the camera around a little bit. When I took apart the other one, it looked a little bit intimidating just to use straight out of the box. The motion control system here, the electronics, I couldn't find drivers for. It looks like it's a well out of date system. It ran off 375 volts, although this one says 240 volts, which I possibly could power up, but I don't want to turn this into a software reverse engineering project. I think what I'm going to do is take off the motion control and the stepper or the servo that's in here, I can't remember, and just replace it with my own system. So let's start off by taking this guy apart and working out how we're going to connect up a new motor system. Let's get to it. Got as far as I could go with my Allen keys. I don't have one long enough to remove this housing over here, at least not easily, but I thought I'd give you a quick overview of what's inside here. It's really nice, particularly if you didn't see my last teardown. Yeah, so the first thing I took off was this motion control box. The motor was attached via this DB15 connector and this 4-pin, Molex connector. Inside here we have a couple of FPGAs. I think that's Firewire input. It's a really nice unit. I'm sure this guy is really cool. Probably on the obverse side we have a bunch of MOSFETs or something similar to drive the motor. Inside the rail section we have a really smooth ball screw. So this looks like 1 turn per inch, a little under, like 3/4. And if this is a stepper motor driving it, which I believe it is, typically stepper motors drive 1.8 degrees per step, so 200 steps per revolution, which means you get 3/4 divided by 200, whatever. You get a few hundred steps per inch. Now with micro stepping, you can go down to like 1600 steps per inch, so you can get quite good resolution out of this. Obviously, I'm just going to be using this heavily overpriced, at least for its purpose, device as motion control for the camera, so I don't need that level of resolution, but it's nice to know. We have really nice ball screws in here. It's super clean, precision linear rail on the bottom. I don't know if you can see any of this, but that's really nice in there. We have a coupler mechanism to couple from the shaft of the ball screw to the shaft of the motor, and a nice bearing on each end. There's probably a bunch of bearings. Let's go talk about the motor. So here we have a close-up on the motor. I think I'm actually be able to use this guy. It does not look so intimidating. Let's go through all the connectors. The first thing is this DB15 connector that was going through to the board. Dangling off here, you see a backup battery, and that connects to the back of the motor here, which makes me believe that this is a rotary encoder. So that'll tell you the angular position, probably absolute given the battery, of where the shuttle is in relation to the slide. Then we have a 4-wire plug here. That looks a lot like a stepper motor to me. You've got 4 wires here. We should be able to identify the pairs and drive that. And we also have this low pressure pneumatic line. I assume that's what this is. I have no idea what that's for. I can't find where it's going. The other one that I took apart had one of these too. I'm going to just claim ignorance and yank it out. I assume it just... Oh, there we go. Well, it was cut off on the end, so that can go in the trash. Who knows what that was for. All right, let's see if I can identify the pairs on this and see if we can just drive it from a regular stepper driver. That would be cool. This is not a stepper motor. I was confused. Well, I was deceived. As I said, there are 4 wires here. I probed all the pairs, and what we have, I don't know if you can see my drawing. I'll maybe come in for a close-up, where I wrote down basically the adjacency matrix or the ohm resistance between each pair. and found that we have a triangle. That means we have a 3-phase motor or a brushless DC motor. That's not a huge problem. I can definitely drive those. I think I have maybe one spare driver around here, but I do want to take the motor out because of the way 3-phase motors work. I don't want to be ramming this sled into the end of the linear rail, particularly because I don't have the rotary encoder connected or worked out. I'd like to get this thing out, test it in isolation, then put it back in here. If I'm feeling comfortable, I'll continue using this motor. If not, I'll switch this out for a stepper motor. But let's see if I can find an Allen key that will reach deep down into here. I think this is the right key, but the screws are back there. I may have to jerry-rig something. Be back in a sec. I made a janky extender using these drill bit extender things. I didn't have an Allen key the right size, but I found a Torx security head. That was the right size. Sorry I can't get a good camera angle for you. I can hardly see what I'm doing here. I've got this little light. But I got the first one out. Hopefully the rest should come out pretty easy. AC servo motor, 200 volts, 2.8 amps, 1.27 Newton meters, 3,000 revolutions a minute. All right, I'm not going to drive a servo that high voltage. The only servo drivers I have are much lower power. So I think I'm going to replace this with a stepper motor. Hopefully it'll have enough torque to drive this. It should be pretty smooth. Nothing is ever as easy as it appears in your head. So I've got the motor out, and this is the closest stepper motor I had. It has a different dimension in 2 ways. The bolt hole pattern is smaller. You can see hopefully that the faceplate here, this motor that came out of this guy is larger, this one's smaller. This is a NEMA 23. I'm not sure what size that is, which means that if I want to attach this motor, I have to mill out new holes for a new bolt hole pattern. The other thing is this has a 14mm shaft, and this is what, a 5mm shaft? 6.3mm, that doesn't seem right. What is that in inches? Is it an inch? 1/4 inch. So I need to make an adjustment to this plate to hold that bolt hole pattern, and I need to make a coupler piece that will slip over here, take that up to 14mm, so I can install in the shaft coupler here. All right, let's get to the lathe. All right, we have our little 1/4 inch to 14mm adapter. Went pretty smoothly. I don't want to press that on too much. The only challenge was the idiot who last did an M4 hole put the wrong tap drill in the wrong spot in my cupboard. So the first hole I tapped was too large. The first hole I drilled was too large. Anyway, no biggie, we now have a speed hole on the obverse side. Threads in okay. If I had the right come on. Too small, too big. Oh, come on. I'm starting to think that there might actually be a better way of organizing Allen keys than just leaving them lying around in various piles. Okay, we're back in the electronics lab. I found myself one of these little micro stepper drivers. Convenient little unit, cheap, does the job. Got it hooked up to power this guy. I'm using my oscilloscope as a function generator. I'm currently generating a 10 kilohertz wave. And if I plug this all in, we should start doing some stepping. And if we turn the frequency up to something a little bit more reasonable, let's go to 1 kilohertz. We have nice smooth motion. All right, let's bring the linear rail in here and see if we can hook them up. Okay, so I've modified this mounting plate to attach this motor. You saw me use the coaxial indicator to find the center of the hole, then use the bolt circle function on the mill to locate this motor. I offset it by 90 degrees so it wouldn't interfere with the existing bolt circle pattern. This video is getting pretty long, so I'm going to end it soon, but it would be a shame to end it without taking some footage from the top of this guy. So I just found a piece of scrap 1/8 inch aluminium. I'm going to mount it up here and let's see if we can take our first footage using the slide. In addition to being god-awfully loud, the vibrations with the stepper motor make their way into the lens. I've learned that if I zoom out, go wide angle like I am now, it's pretty hard to see, but I think maybe a servo motor would have been better for this. But pretty happy. Next up, in the next video, I'll do some more electronics and build out a second axis for rotation. Until then, keep well, see you next time, bye.